This is part 2 of the lecture on chapter 2. We will talk about the atomic number and the mass number, two very important things when we talk about elements in the periodic table. So let's take a look at a modern periodic table and what it looks like. I'm not going to focus right now on the individual elements, but I want you to see, if I look at one particular one, in this example that we have here on sodium, if you look at one of these squares, it has several different parts to it, and it gives us useful information about each element. First of all, we have the symbol for that element. Na, for example, is the symbol, the shorthand symbol for sodium. Now you might wonder, why is it Na and not So? Well, that's because it was named after sodium in Latin is natrium, and that is why it's an Na. It just doesn't come from the English word. So all of these little squares contain shorthand notations for all of the elements. They're called symbols. And then right above each element, or in this table here, it's to the top left-hand corner, what we find is numbers, and they start with 1 and they keep going 1, 2, 3, 4, etc., until you get to the very last element and then some of the periodic table. This number that is above the symbol in the periodic table is called the atomic number, and it's designated with Z. That is what its symbol is. So Z is the atomic number for an element, and it is found right above it in the periodic table. So if I told you what element is number 13, you should be able to go up here and find, okay, 1, 2, 11, 12, 13. Aha, there's my element. Element number 13 is aluminum. Element number 6 is carbon. Element number 8 is oxygen, and so on and so forth. So the atomic number, Z, is found above the element in the periodic table, and it tells us what the element is in order. Where does it fall in order with all the other elements in the periodic table? Now, the interesting thing, the atomic number also tells us the number of protons that particular element has. So Z here, the atomic number, is equal to the number of protons. This is a very important thing to remember. The easiest way then to know how many protons, for example, sodium has, is to look at its atomic number, and that tells me it has 11 protons. The protons in a nucleus of an element are like its fingerprints. If I change the atomic number, so if I go from 11 to 12, you see I added 1 proton, and now I don't have sodium anymore. I have a completely new element, which is magnesium. So if you change the number of protons of an element, you change the element completely to a different one. And if you change the atomic number, because the atomic number designates the number of protons, it's the same as changing the protons, therefore changing the element, the identity of the element. So think of the atomic number, or the number of protons, as the fingerprints for that particular element. Very important. Then the next thing that we're going to talk about is the atomic mass. It is designated with an A. A for atomic mass, Z for atomic number. The atomic mass is typically found below the symbol of the element in the periodic table. Here is sodium, for example. In this table, it tells you the number, the atomic number. It tells you the symbol. It tells you the name, the actual name of the element. And then right below it, it gives you the atomic mass. Note that the atomic mass is larger than the atomic number, and that is because the atomic mass includes the number of protons and the number of neutrons of an element, whereas the atomic number only gives you the number of protons. Therefore, when we want to calculate how many proton or neutrons an element has, all we have to do is take the atomic mass and then subtract the atomic number from it, and it gives us the number of neutrons. So here's the formula. A minus C equals number of neutrons. A is the atomic mass, the bottom number, minus Z, the atomic number, the top number, gives us the number of neutrons. Very important to remember. So if I gave you an element, you should be able to tell me what the number of protons is, what the number of neutrons is, because you assume this is 23, about 23, minus 11, that's 12, so sodium will have about 12 neutrons. You should be able to tell me the number of neutrons. You should also be able to tell me what the number of protons is. Remember that every element that appears in the periodic table the way it is, sodium for example, if they appear in the elemental form, they don't have a charge. The charge is 0, which means that where does a charge come from? Well, I have positive charges and negative charges. My positive charges are protons, negative charges are called electrons. In an element, in a neutral element, where the overall charge is 0, my protons have to equal my electrons. My positive charge equals the negative charge, that way they cancel out. And therefore, the number of protons will always be the same as the number of electrons. This is in a neutral atom, not in an ion. We will talk about the ions, but in a neutral atom, the number of protons equals the number of electrons. So this sodium, for example, with atomic number 11, it will have 11 protons, also 11 electrons, and it will have what we calculated earlier, about 12 neutrons. Here it is, atomic number, number of protons, and then mass number or atomic mass. It's the same thing, it's number of protons plus number of neutrons, so that you can calculate the number of neutrons by taking the mass number and subtracting the number of protons. Now, let's look at an example of some sort of problems the kind of problems that we will encounter when we do atomic numbers, protons, and neutrons. Hydrogen, for example, has an atomic number of 1, which means that every hydrogen atom has 1 proton. It doesn't matter where the hydrogen is found. It can be found in the stars, it can be found here. It will always have 1 proton. That's what makes hydrogen a hydrogen, that it has 1 proton. Carbon has an atomic number of 6, which means that every carbon atom will have 6 protons. Copper has an atomic number of 29, which means every copper atom has 29 protons. Gold has an atomic number of 79. It's number 79 in the periodic table, means it has 79 protons, and so on and so forth. An atom, we just mentioned this, an atom of any element is electrically neutral. It doesn't have a charge, meaning it has an equal number of protons and electrons, because if you have a positive charge that is equal to a magnitude to a negative charge, the sum of these two will be 0, so it has a net charge of 0. Any atom of any element. So a neutral atom of calcium, which has an atomic number of 20, contains 20 protons and 20 electrons. It has a 0 net charge because plus 20 minus 20 gives me a 0. Very important thing to remember. An atom of an element is electrically neutral. This doesn't include, as I said, doesn't include ions, but we're talking about atoms right now, not ions. Atoms are electrically neutral, and therefore the protons are equal to their electrons. I have made videos of these next couple of slides because they're problems to show you how to fill in this table here for sodium, zinc, and sulfur. I also have made, in that same video, I've shown you how to do the ion as well, how to fill this table for the ion, so sodium plus, zinc 2 plus, and sulfur 2 minus. So watch the video to see how to fill out this table. And then the last problem for this section is also similar to what we were doing, but for this one, we also had to figure out the number of neutrons, and then I did these ions as well. So once again, watch the video and let me know if you have any questions on that. This concludes this section of Chapter 2 lecture, and we will continue with the isotopes.